If we're looking for vertical asymptotes, that's when the denominator is equal to 0. Okay, so the equation of vertical asymptote is x equals -2. All right, what is the horizontal asymptote? Okay, if there's a couple ways of doing this, but probably the best way is to recognize that the reciprocal function is existing here. And the reciprocal function looks like this. Then it's the parent function 1 over x. Okay, so 1 over x has the horizontal asymptote right there at y equals 0. If we add 6 to the entire function, okay, just like any other transformation, it moves everything up 6 units. So every point on this curve is going to go up 6 units. Every point on that curve is going to go up 6 units. And then every point on the asymptote also moves up 6 units. So it was at y equals 0. The new horizontal asymptote is at y equals 6. Here we're looking at the appropriate information down here. First you have to factor. So I factor the top. It becomes x plus 3, x minus 3, all over x minus 3. Now, we talked about that being, because those cancel out, that is a whole at x equals 3. Okay, so looking down here, there's a hole in the graph at x equals 3, option D. Okay, so as the graph, the rational function f of x is given, use the graph to find the following information. When is f of x equal to 0? Well, f of x equals 0, that is right there at -3. Okay, so that's part A. When is f of x less than 0? So that's when are we below the x-axis. So it's those values there. Now we're recognizing that there's an asymptote here. Okay, looks like an asymptote at 1, or sorry, not 1, 0. Okay, x equals 0. And then after we get past that asymptote, we come back up here. So we're below 0 from -3 to 0. So this option here, -3 to 0. All right, now we don't include, we want to be below 0. We don't want to be equal to 0, so it's a parenthesis, not a bracket. Now we want to find greater than 0. Okay, this portion here is above 0, so that's an x value of -infinity all the way up to the x value of -3. Okay, and then past 0, we're back above the x-axis, so that stuff is from 0 to positive infinity, and then all we have to do is take that and union them, and that's going to be option C, or part C. Okay, this question here, you need to find common denominator and multiply everything by common denominator. I think most of you, and the things that I've been working with you on individually, are going to rewrite this as 4 over x plus 1 minus 5 over x minus 1. And a lot of us are recognizing that if we take a negative out of there and put it up top, okay, the bottom then changes to x squared minus 1. Now we can take that and recognize that the x squared minus 1 factors to x plus 1, x minus 1. There's the common denominator. Okay, and we'll multiply everything by x plus 1, x minus 1, x plus 1, x minus 1, x plus 1, x minus 1. Cancel, cancel, and it leaves me 4x minus 4. Cancel, cancel, and it leaves me minus 5 times the quantity x plus 1. People are messing that up right there because there's a negative sign there that we need to distribute through, and this gives me then negative 4x. So you get 4x minus 4 minus 5x minus 5 equals negative 4x. Okay, so that's 8x. If I move that over, I get 8x minus 5x is 3x. Some x's are gone, and then I'll move this negative 9 to the right hand side. I get 9, so x is 3. All Right? The only thing I got to pay attention to when I get my answers here is that amount there, that amount there, and that amount there. When I plug back the 3, I do not get 0 on the bottom. In this case, I don't. This question is very similar to the last one. Okay, so I'm going to start you on, so I'm not going to do the whole thing for you, but you got to factor. I have 1 over x plus 1 plus 3 over x plus 3 equals 2 over x plus 1 x plus 3. So now, common factor, x1 plus x3, x plus 1, x plus 3, x plus 1, x plus 3, cancel, cancel, leaves you x plus 3 when you multiply, cancel, cancel, leaves you 3x plus 3 when you multiply, and then equals 2 times, well, those things cancel out, so I just left with 2. Solve this, you get 4x plus 6 equals 2. 4x equals negative 4. X then equals negative 1. But that's an issue right there. X is only equal negative 1. Can't be negative 1 there. So there's no solution. The only possible solution just got canceled out because it's a domain restriction. Here we need to rewrite these as rational exponents. So it's x to the 1/3 times x to the 1/7. So when I multiply like bases, I'm going to take those exponents and add them. So the only way I can add them is if they had a common denominator. Common denominator is going to be 21. So this becomes 7 over 21 times then x, and this is going to become 3 over 21. Okay, so now I add them, I get x to be 10 over 21. And that's what they're asking for right there. Okay, here we've got nested radicals. So like I said in class, we want to work on the innermost part. So I'm going to take that and rewrite it as b to the 1/8, right, with rational exponents. Okay, now I'm going to multiply these b's on the inside together, so they have to have a common denominator to add their exponents. So I get the square root of b to the 9/8. Okay, well, we talked about how we can do this. Okay, which then gives me b, square root of b is the same thing as b to the 1/2. Raise that to the 9/8. Now I've got a power to a power, and I get b to the 9/16 when I do that. And that's what they're looking for as the answer. Okay, here it says determine the domain of the function analytically, so that means by hand. So when we do this, what we're looking for is this amount there, 4 minus x squared, has to be greater than or equal to 0. Okay, well that's 2 minus x, 2 plus x, has to be greater than or equal to 0. Alright, so that gives me a root at 2, and negative 2, I've got to try a sign chart here. Remember, whenever we have non-linear inequalities, you set up a sign chart. Okay, so I put negative 2 there, I put 2 there, I put both factors, 2 minus x, and 2 plus x over here, and then my total. If I choose a number like negative 10, 2 minus negative 10 is positive. 2 plus negative 10 is negative, so my total is negative. Okay. If I try a number like 0, I get 2 there, so that's positive, and I get 2 there, so that's positive. So my total is positive. If I try a number like 10, 2 minus 10 is negative, 2 plus 10 is positive, and that's negative. So I'm looking for, will be greater than or equal to 0, so I'm looking for positive numbers here, or equal to, so I can have those there. So we see that -2 to +2 is positive values. Those are the ones greater than or equal to 0. So my result here is that one. And I can include those, so I can have those brackets. Okay. Again, a radical equation, so I've got to isolate the radical part. So I'm going to go radical x minus 6 equals x minus 8. Square both sides gives me x minus 6 equals x minus 8 squared, which that becomes x squared minus 16x plus 64, and this is still x minus 6. Okay, square that, multiply them together and double, and then square the last term. Now I'll move the x over, so it gives me 0, x squared minus 17x. I'll add, so plus 70, so that's going to be x minus 10, and x minus 7 equals 0, so x is 10, x is 7. You just have to make sure then that when you plug back in up here, they both work. So 10 minus 6 is 4, square that, or square root that, it's 2, 2 plus 8 is 10. So yeah, that works. That one is a solution. Okay, now if I plug 7 in, I get 7 minus 6 is 1, square root of 1 is 1, plus 8, does that equal 7? That's a false statement. That's my extraneous solution. X is only 10. With question number 10 here, we are going to try to isolate one of the radicals. So I'll just leave the one on the left alone. And I'll move the one on the y minus 2 one to the other side. So that's 3 plus square root of y minus 2. And now that we've isolated, we can square things. So I'll square that, and I'll square that. So it gives me 4y plus 1. Now radical y minus 2. So first, okay, so you mean or 3 radicals, a total of minus 1 equals radical y minus 2. So I'll multiply everything by 4, so we get y squared minus 4y plus 4 equals 4y minus 8. I will move everything over, gives me negative 8y. And y is 6. Question number 11 asks you to find whether there's vertical asymptotes, holes, or no discontinuities. You have to factor. So when I factor the bottom, it's going to be x minus 2, x minus 3. The top is x minus 3. Okay, so those cancel out. So there's a hole at x being 3, and there's a vertical asymptote at x equals 2. In this one, what you're looking for is you get a factor. So when I factor this bottom, top stays x minus 8. Bottom is going to go x minus 8, x minus 4. So when they cancel, x minus 8's cancel. That tells me a hole at 8. And this didn't cancel, x minus 4 didn't cancel, so that tells me an asymptote at x equals 4. Okay, here it wants to know where's the horizontal asymptote. Well, if I look at those two leading terms and the bottom's bigger, I don't have an asymptote or horizontal asymptote. I have a slant asymptote, and I'd have to do a long division. So there is no slant or horizontal asymptote. 15 here. Okay, I'm going to go through and factor everything. So I go through and factor everything. The top has an x in it, so that's going to be x squared plus x minus 20. Okay, so that's going to factor a little bit further to x minus 4, x plus 5. And now the bottom is going to factor x minus 7, x plus 3, negative 21. Yep. Okay. So now it says what's the domain? Well, x cannot be 7, x cannot be negative 3. So when I look at this, those are the values then that showing I can't be negative 3. This is showing you right here that we're not going to include negative 3, and that's going to show you right there that we're not going to include 7. So what are the x-intercepts? X-intercepts are when the numerator is equal to 0. So x is equal to 0, x minus 4 is equal to 0, and x plus 5 is equal to 0. Solve those, and those give you x-intercepts. Y-intercept is when x is 0. So if x is 0, I'm going to go back to the original function to do this. When x is 0, my tablet, give me 1 second, my tablet died. Okay, so y-intercepts when x is equal to 0. Well, if that's 0, if x is 0, that goes to 0, that goes to 0, that goes to 0. Bottom's going to be negative 21. So y-intercept is 0, 0. Okay. And choose the corresponding graph over here. Plug all those pieces of information in and see which one matches up. You're going to have a slant asymptote because those things are different. It doesn't ask you about the slant asymptote, but if you look at all these, that one can cancel out because I don't think it has a slant asymptote if I zoomed in on it. So it's down to these 3, and I just have to do that long division then to see what the slant asymptote is. Or if you just type that in your calculator, see which one matches up. That'd be probably the quickest way on the test. Okay, find the vertical asymptote, domain, x and y intercepts the function. Same idea, okay? Vertical asymptote right there. Okay, so x at negative 1. Choose the correct domain. Well, x cannot be negative 1, so it's all real numbers except for negative 1. So there's my domain. X-intercepts are 1, 0, and, okay, so what they're telling me right now, they're already giving me one of the x-intercepts. The other ones, x-intercepts always come from the numerator equals 0. So that thing's going to factor to x minus 1 and x minus 3. So this comes from that factor, so that factor must give me another one at 3, 0. Y-intercept, again, it's when x is 0. 0, 0, 0. What you're left with is 3 over 1, so the y-intercept is x is 0, y is 3. Okay, now Again, you're going to have a slant asymptote because those two things are different. Okay, and this one's smaller than the top. So look at these three, along with the slant as. Looks like all the slant asymptotes are kind of the same. Fill in that information. You're going to pick the best graph. State whether the following statement is true or false. Explain the x-axis is a horizontal asymptote for x, or f of x. Okay. Well, if I look at that, horizontal asymptotes are found by taking those leading terms and divide them. X squared over x to the fourth. That eventually give me 1 over x squared. When x gets really, really big, this becomes 1 over a huge number, which goes to 0. So I'd have a horizontal asymptote at y equals 0. Is that the same thing as the x-axis? In this case, it is. So we would say true because the numerator and the denominator contain terms with the variable x. True because the degree of the numerator in the given rational function is less than the degree of the denominator in the given rational function. So it's option D. That's our answer. 18. Find the domain of the rational function. X cannot be negative 5. So I'll go negative infinity up to negative 5, union, negative 5, positive infinity. Find the domain. X cannot be negative here, cannot be 0 here. So x squared minus 2x minus 35 cannot be 0. That factors to x minus 7. X plus 5 cannot equal 0. So this is going to be x equals 7. X equals negative 5. Those are what x cannot equal. So negative infinity, negative 5.
Question number 20. Find the oblique asymptote and sketch the graph of the rational function. So you're going to take negative x cubed plus 2x squared plus 4x minus 1 and divide it by the denominator, x squared plus 2x minus 5. Now you're thinking of a number that multiplies by x squared to give you negative x cubed. So it's going to be x, negative x. So it gives me negative x cubed. Gives me minus 2x squared, and it gives me plus 5x. I'm going to go through, change all the signs, and I'm going to add straight down. So those cancel out, gives me 4x squared, it gives me minus x minus 1. Now I need a number that multiplies by x squared to give me 4x squared, so it's plus 4. That'll be 4x squared plus 8x minus 20. Change signs. Add straight down, so I get negative 9x plus 19. Now because that x has a power of 1 and this one has a power of 2 up here, I know that's a remainder. So all I'm interested in for the slant or the oblique asymptote is the quotient. So y equals negative x plus 4. Now looking at these over here, I know that the slope is negative. So I'm looking at the slant asymptotes. So slant asymptotes are that line there, that one there, that one there, and that one there. Okay, those are the slant asymptotes. I know the slope's negative, so it can't be that one, and it can't be that one, because those slopes are positive. So I'm going to look at this one here, B and D, and I'm going to try to look at, I'm going to have to blow them up, but whichever one of those slant asymptotes crosses at positive 4 would be the one that on the y-axis, that's the y-intercept, whichever one crosses at 4 would be the one I choose. With this one, okay, it's a rational inequality, so we've got to be greater than 0, so that means at the end we're looking for positive results. We're going to factor it, so factors the y, or w minus 4, w plus 3, and w minus 2 on the bottom. Those give me then the zeros of negative 4, or positive 4, negative 3, and positive 10. I'm going to put an open dot at 10 just to remind myself that I can't use that because it's in the denominator. And now I'm just going to go find signs. So if I choose a number to the left of negative 3, like negative 10, it'll be negative, negative, negative. So the total is negative. In the middle here, 0 is in the middle, so I'll choose 0. So it's going to be negative, positive, negative. So that's a positive. Now I'm going to check a number like 6. So 6 minus 4 is positive, 6 plus 3 is positive, 6 minus 10 is negative, so total is negative. And then a number like 12. 12 minus 4 is positive, 12 plus 3 is positive, 12 minus 10 is positive, so my total is positive. Again, at the beginning we wanted to say we're looking for positive values, so that's there and there. And we can be greater than or equal to, so equal to at 3, negative 3, equal to at 4, can't be equal at 10 because that's the denominator. So graphically those are the answers. I'm going to write that as negative 3 to 4, union 10 to infinity. This one they want to know when is the curve equal to the line x plus 3. So they're equal right there where they cross, and that's an x value of 0. All right, now they want to know when is the curve below the line. So here's the curve. Let's see if I can highlight this. They want to know when is that curve below that line. Okay. Well, the yellow is below the green, starting at 0 and going to the right. So 0 to infinity. So right there. They want to know, and it's below or equal to, so that's why we started at 0 and include 0. Now they want to know when is the curve, when is the yellow greater than the line. So when is the yellow above the green? Well, the yellow is above the green over here, so it's these x values. So some people might say, well, I'm going to go from negative infinity up to 0. But the yellow doesn't exist all the way at negative infinity. The yellow only exists at negative 9. So I go negative 9 to 0, and I'm going to include negative 9, and I'm going to include 0, because we've got that equality there. This one, we're going to cube both sides to get rid of that 1/3. So when I cube it, I get x squared plus 2x. Cube 2, I get 8. So now I have x squared plus 2x minus 8 equals 0. That's going to be x minus 2. X plus 4 equals 0. X is 2. X is negative 4. I just got to make sure that when I plug back in, I get true statements. So when I plug in 2, I get 4 plus 4 is 8. The cube root of 8 is 2, so that works. When I plug negative 4 in, I get 16 plus negative 8, which is 8 again. 8 cube root of 8 is 2, so negative 4 works. This one here, you gotta get rid of this outside radical first. So I'm gonna square both sides. So when I square both sides, you get 61x plus 13 equals 4x plus 2. Now I still have this square root, so I need to square again. So 61x plus 13 equals square this side. So 16x plus, 16x squared plus 16x plus 4. I'm going to go ahead and move when I move everything over, I'm going to get 0 over here, be 16x squared minus 45x, and then minus 9. Using my a times c method, when I take 16 times negative 9, 16 times negative 9 gives me negative 144. Now I'm thinking about two numbers that multiply together give me 144 and add up to negative 45. And those two numbers are 3 and 48, and the 48 has to be negative. So I'm going to have 16x squared minus 48x plus 3x minus 9 equals 0. Factor out of 16x out of the front 2. It gives me x minus 3. Factor out of 3 out of the back gives me x minus 3. So my factors are 16x plus 3 and x minus 3. This is all equal to 0. So it's going to give me x to be 3, and it gives me x to be negative 3/16. When I solve those, and both of those end up being solutions here for this problem. To answer this question, you could have graphed it and seen when is the left-hand side above the line y equals negative 1. All right, and that's going to be, I believe, if you were to graph it, you're going to find it's option A. It's between negative 10 and 11. But if I'm going to do it by hand, I need to isolate
one side of the, or sorry, one radical. Okay, but before we do that, remember when we had radical inequalities, we first had to decide what value, we had to decide domain values basically. So what values x could be here. So we say x plus 10 had to be greater than 0 or equal to 0. And that's going to say x is greater than or equal to negative 10. But then at the same time, because we're using the same x value, that 11 minus x had to be greater than or equal to 0 as well. So it says x has to be less than or equal to 11. So I write that on my number line. Negative 10 and 11. And on my number line, x can only be those values. Okay, between those. Now, we might be able to narrow it down between those, and that's what the next algebra is going to do, is see if we can narrow down. Maybe it's only between negative 8 and 11, or maybe it's only between negative 10 and 6, or something like that. So we got to do further algebra here to find some more points up here. So what we do is we solve the accompanying equation. So I'm going to take radical x plus 10 equal to negative 1 minus the square root of 11 minus x. I'm going to square both sides to get rid of this square root, so it gives me x plus 10 on the left. Now when I square the right hand side, it's going to be negative 1 times negative 1, which is 1. It'll be these two things multiplied together, so it gives me a positive 1 and then this square root, but then I double that, so it's going to be a positive 2 and that square root of 11 minus x. And then last times last will give me plus 11 minus x. So when I start moving, I want to isolate this radical now. I'm going to move the x over, so it gives me 2x. I'm going to move this 12 over, so it gives me minus 2 is equal to 2, 11 minus x. Divide everything by 2, it gives me x minus 1 is equal to square root of 11 minus x. I'll now square both sides, so it gives me x squared minus 2x plus 1 over here, and 11 minus x over there. I'll solve this for 0 then, or set this equal to 0, so I'll add x to both sides, so it gives me x squared minus x, and I'll subtract 11 from both sides, it gives me minus 10. Now, I'm going to have to use the quadratic formula to factor that, okay? So give me 1 second, and I'll do that, and I'll come back with that factored form. So once I use the quadratic formula, it provides me these two results. So I'm going to change those to decimals just to make things a little bit easier. And when I change those to decimals, I'm going to get approximately negative 2.70, and here I get positive 3.70. So I'm going to put those up here. Negative 2.7 and then 3.7. So now what all I have to do is I broke up into 3 intervals. I got to try a value in each one of these intervals back into the original inequality to see if I get true or false statements. So in this interval here, we got a number like negative 5. So if I put negative 5 in, I'll get radical 5 back. If I put negative 5 in here, I'll get radical 16 back. If I add those together, I'm going to get a number bigger than negative 1. So that's a true statement. Now in this interval here, 0 exists, so I'm going to plug 0 in. I plug 0 in, I get radical 10. Here I get radical 11. If I add those together, I will get something bigger than negative 1. So that's true as well. And now I'm going to try a number between 3.7 and 11. So I'm going to try, 10. If I plug 10 in, I get 20, square root of that. Plug 10 in here, I get square root of 1. If I add those together, that's something bigger than a negative number, so that's true as well. So I got true values in there. Sometimes you might get a false value in one of these intervals. It's just the nature of the problem. Here, it's true everywhere, so my end result is negative 10 to 11. Okay. Now, because this was greater than, I can't be equal to there, and I can't be equal to there. All right, because that will actually give me negative 1, and I don't want that. So I'm going to open parentheses, and obviously you see everybody had choices here, and the way they're all set up is none of them are going to have brackets. So if you miss that part, you should still see the answer that you found over here.